Subscribe now and click on the bell icon to never miss learning from Vedantu.
We are going to start with electrochemistry today. Chemical energy can be converted into electrical energy and vice versa. I hope I am audible, hai na? I'm audible, just type yes or no. Type yes or no. That's okay. So in between na beta, if I ask this question, you just type yes, you are audible. Few of you, so that one of your friends who is saying you are not audible, so he or she can know that something wrong from your end. Lisha, good evening. Ab chup bete, please listen. Chemical energy can be converted into electrical energy and electrical energy can be converted into the chemical energy. That is what we are going to discuss. We will discuss that electrical energy can even derive few non-spontaneous reaction. We are going to discuss that electrolysis is a non-spontaneous process. Electrolysis does not happen, but electrical energy can even derive it also. Study of this topic will help us understand the principle behind production of large number of metals and chemicals. I assure you, whatever I am going to teach you in this chapter, that will be the best notes for your any type of school type test or maybe competitive type of test. Nowadays, we are converting chemical energy into electrical energy. What is happening in your batteries, maybe the cell phone battery, maybe this battery, which are very efficient and less polluting. Space missions are using energy from hydrogen oxygen fuel cell, and the water produced in such processes is used for drinking by astronauts. Transmission of sensory signals from brain to cells and vice versa are electrochemical energy. This has developed so much that we can make the person who is unable to see, the blind person, see maybe in the coming years. Electrochemical cells are extensively used for determining the pH of the solution. We will see to this in this session. This chapter. Solubility product, KSP, equilibrium constant, redox reaction. Redox is reduction and oxidation both happening. Large number of metals, sodium hydroxide, chlorine, fluorine, and many other chemicals are produced by electrochemical methods. It will be a very important topic. Batteries and fuel cells are used to convert chemical energy into electrical energy. The reaction carried out electrochemically can be energy efficient and eco-friendly, right? The transmission of sensory signals and have electrochemically, therefore electrochemistry is going to be a vast and interdisciplinary subject. And this is a topic where all of you will be making notes after the session with your on hand, right? So whatever I know, I will try to transfer into your notebooks and then it will be going to your mind. And beta, the topic is very important. I think you should totally concentrate, right? The moment you are not following me, you will miss the topic and there will be a large gap which will be very difficult for you to cover. It is the most basic of all the chapters and I have to tell you a lot. Chalo. We know electrodes. Electrodes, how it is, are of two types. What are electrodes? Where electron gain or loss may happen. Cathode, anode. We have two types of cells. One is going to be energy producer, which is known as galvanic cell. Another is going to be energy consumer, which is electrolytic cell or any battery, any apparatus where you give energy from outside is going to be energy consumer cell. See your cell phone. Right now it is producing energy. And after little bit of time, maybe few hours away, you are going to recharge it. At that time, it becomes energy consumer cell. Cathode is a positive electrode in energy producer cell and it becomes negative in energy consumer. Producer may positive and consumer may negative. While anode is a negative electrode in energy producer and it is a positive electrode in energy consumer cell. The way to memorize it, yes, of course, Dipesh. Cathode, anode. Chartered accountant, first you produce and then you consume. energy producer, consumer. If I ask you to write plus and minus, or normally you will write plus first. So here you write plus, here you write minus. If it is plus here, write minus and plus here. Okay. So that is an important thing for you. Electrochemical cell. A cell is a system or arrangement in which two electrodes are fitted in the same electrolyte or in different electrolyte which are joined by a salt bridge. Wait, it will be discussed in detail. The free energy delta G associated with the chemical transformation is known as chemical energy. There are two types of cells. One is going to be electrolytic cell. Electrolytic cell is going to be which will be causing electrolysis, right? And another is going to be galvanic cell. Electrolytic cell is energy consumer cell. And galvanic cell is going to be energy producer cell. You have to learn a lot during this thing, right? Continued. Electrolytic cell. Please do not memorize till the time I write CTM. Okay. So do not memorize anything. Nothing to be done, beta. The whole topic is going to start. And please concentrate. Please concentrate. Do not memorize anything. Please do not memorize anything. Okay, dear? Electrolytic cell. In this cell, right now, I will just brief you about electrolytic cell, and afterward, maybe around 3 to 4 sessions after this, we are going to discuss electrolytic cell in detail. Right now, it is just an introduction going on. So, yes, Bhakti, we had just started with electrochemistry. Rather, we have not started with electrochemistry. We are just touching its background. In electrolytic cell, electrical energy is converted to chemical energy and electrolysis is carried out by passing electricity. Remember, electrolysis is a non-spontaneous redox change. So you can imagine if you have NaCl, right? You put one nail, you put another nail, will it ever convert into sodium and chlorine? No. It is a non-spontaneous. For electrolysis, delta G is positive. I'm sorry, I wrote 0. Delta G is positive. We deliberately make it happen by passage of DC current, right? Which takes place only on passing electricity. That is, delta G is greater than 0. The positive terminal is anode, where oxidation takes place. And negative terminal is cathode, where reduction takes place. Give me time, I will explain this in detail later on. Everybody please concentrate upon what I am saying. Don't be restless, beta. So in your class, are you just asking question? All of you are asking question? No. So if you want to be a good scientist, big scientist, right? First, develop your observation. You are learning first, beta. Okay? Chalo. It derives the process away from equilibrium, right? Everyone is unmuted. An electrolytic cell contains two electrodes that dip into electrolyte and are connected to a battery or some other source of direct electric current. The process of decomposition of electrolyte by passing electricity is known as electrolysis. Just read it. I do not want right now that you are going to memorize anything. Galvanic cell, we have two types of cell. One is electrolytic cell and another is going to be galvanic cell. Galvanic cell is going to be discussed maybe few slides later on, just few slides later on. Galvanic cell. This is the base of the chapter, oxidation and reduction. We have many definitions of oxidation and reduction. Arey beta, don't worry about you are unmuted or muted. Just keep quiet. Oxidation. Siddharth. Oxidation is loss of electron, where reduction is known as gain of electron. It is chlorine goes to chloronium ion. This is loss of electron. This is chlorine plus electron forms chloride ion. This is going to be reduction. Oxidation. O for oxidation, O for oxygen, right? X for halogens. Oxidation is gain of oxygen. You have methane. You form carbon dioxide and water from it. This is going to be termed as oxidation. You have benzene. You make chlorobenzene from it. This is going to be termed as oxidation. Loss of oxygen or halogen is known as reduction. You have, say, methanol. Don't memorize any reaction. Just see to the concept. We add some reducing agent. You get methane. That is going to be known as reduction. Electronegative element. Oxidation is loss of hydrogen. The same definition which you have done here. And it is the gain of hydrogen. These are going to be the three basic definitions for oxidation and reduction. And you will see when you grow in chemistry, you will use these definitions more often than oxidation or reduction. It is not always possible to see electrons moving. So what we see these type of definition. Those who cannot remember them, just Guru Mantra for you people, O for oxygen, O for oxidation. Gain of oxygen is known as oxidation. If one thing is clear, that is obviously the opposite. It is loss of oxygen and it is loss of hydrogen. Correct? Oxidation and reduction. Yes, certainly yes. Oxidizing agent, it will be used many times during the chapter. So I'll be calling it OA. Reducing agent, beta RA. So no, this chapter is unlikely the solutions or the kinetics you have seen. This chapter is highly based upon knowledge. So please help me in build up a knowledge bank with you. So if you are just asking irrelevant question, beta, that is not going to help. Okay? Oxidation and reduction. Where reagent? Mirnak, which type of reagent? Please. Everybody please mute yourself. Mirnak, bolo.
The oxidizing agents and reducing agents are named opposite, sir. Like
please hold on. I have not explained it. Just wait. Okay. I have not explained it, right? Just wait. I was going to explain and there was a blast of question coming, beta. I was not able to explain it.
Okay, sorry, sir.
Okay.
Yes, sir.
So, oxidizing agent and reducing agent. I never went here. Oxidizing agent causes oxidation, whereas reducing agent causes reduction. And oxidizing agent themselves get reduced, right? If they are going to gain electron, only then the samne wala is going to lose electron. So oxidizing agent themselves get reduced. You have seen it that we have KMnO4. KMnO4, when we did ABN, KMnO4 from +7 goes to +2 or maybe whatever it is. So whatever it was gain of electron. Oxidizing agent itself get reduced. And common oxidizing agent, the list can be around 50 or 60, which we are going to learn in this year chemistry. But a few common oxidizing agent are KMnO4, dichromate or nitrate. Whereas reducing agents, please unmute yourself. All of you mute yourself. Reducing agent causes reduction, bachcho, and they themselves get oxidized. Ulta. Reducing agent oxidized, oxidizing agent themselves get reduced. You might have seen maybe 10 or 20 reducing agent. The list will be ever growing. Zinc HCl, iron steam, sodium ethanol, and it is a hydrogen in the presence of nickel, platinum, palladium, etc. These are going to be few reducing agent. It's again going to be an important topic. Is it clear? Now the true chapter has started. From this slide, the true chapter has started. Oxidation reduction, and this is going to be oxidizing agent and reducing agent. Going ahead. Types of reactions which we are going to discuss. The first is reduction and oxidation. So it is reduction, the 3 words, and oxidation, the 2 words. It is redox. The collective word is redox. For example, if you see ferrous, it is sitting in +2 oxidation state. Ferric has gone into +3 oxidation state. manganese is sitting in +7 oxidation state. Now it is sitting in +2 oxidation state. So manganese is being reduced and iron is being oxidized. Oxidation reduction known as redox. Zinc goes from 0 to +2. Oxidation. And hydrogen from +1 goes to 0. Reduction. We are going to call this as well as this type of reaction as redox reaction. These are really infinite reactions. Yes, most probably yes. Don't worry about that. There is no change in oxidizing power, or you may call it oxidation number. Sulfate is here, sulfate is here. It is simply aiding in the reaction. That is my practice. That is my practice. Now see, disproportionation. That means self-oxidation and reduction. Means the same species get oxidized, the same species get reduced. For example, copper is sitting in the +1 oxidation state, bacho. It is going to the +2 oxidation state. And it is going to 0 oxidation state. From +1 to +2, what is happening? It is going to be the oxidation. From +1 to 0, it is going to be known as reduction. Similarly, in H2O2, you remember oxygen is sitting in the -1 oxidation state. So it is going to -2 and it is going to 0. So what is happening? Reduction. What is happening is oxidation. Disproportionation. Self-oxidation and reduction. Hanji beta, neither oxidation nor reduction. Neither oxidation nor reduction. Neutralization is such a reaction. Sodium ion, OH negative. H plus, negative ion. Sodium ion, negative. H plus, OH negative. Neither of this is being oxidized or reduced. That is going to be the neutralization reaction. Double decomposition, or you can call it double displacement. What is double displacement, beta? Silver nitrate, this sodium minus plus minus plus minus. Okay, the oxidation state is bacho not changing. It is not changing. So we call it double decomposition. I have already unmuted you all beta. So if you want to ask a question, please ask it. Okay. Neutralization should not be called as double decomposition or double displacement. Right? So please do not give names yourself. Follow whatever has been happening in the word. Okay. Double displacement beta. ये देखो ना, silver के साथ we put chloride and silver nitrate has been decomposed and sodium chloride has been decomposed. We call it double. This has been decomposed. This has been decomposed. Double decomposition. Double exchange. Whereas if you see this reaction, this is simply known as displacement. Displacement. Zinc has displaced hydrogen. Whereas this is, you can say silver has replaced sodium and sodium has replaced silver. Double displacement or double decomposition. It's the same thing. Most probably you are already reading about these reactions from class 8th or 9th. Okay, chalo. Be quiet. If you want to ask a question, I have given you the way. You can ask question, most welcome. But that topic should be related to my electrochemistry. That is a restriction on all of you. Okay, bachcho. Chaliye. I'm going to start with a topic that is going to be known as types of energy producer cell. See, I have put my phone on charging. Right now, this battery is energy consumer cell. Right? It is taking energy. Now I have unplugged it. Now it is a energy producer cell. That's it. You have battery in your car. So when it is giving energy to you, it is producing energy. And when it is being recharged, it is going to be a consumer cell. It's as simple like this, son. Okay, Nayan? Chalo. This chapter is going to be highly rewarding, my bachcho. But It is based upon knowledge. The more knowledge you have, and I will give you all the base, rest all is practice from you people is expected. This is an actually scoring topic, and this chapter will give command upon equilibrium, thermodynamics, all the topics. Chalo bhai, please start. We have two types of energy producer cell. Right now we have focused upon energy producer cell. We have types of energy producer cell. One interesting question has come. I am going to take that. Can a single cell act as energy producer and consumer? Yes. What is happening in your inverter battery? What is happening in your cell phone battery? What is happening in your cordless battery? You use it, you recharge it. There are thousands of this. Types of energy producer cell. The first cell is a direct cell. In these, oxidation and reduction happens in same vessel. And no useful work, that is electrical work, can be obtained. See an example. You have a container in which you have added copper sulfate. Copper sulfate is blue in color. Then you stir it with a zinc rod or aluminium rod. What has happened? You have a container in which you have copper sulfate. You're going to move a zinc rod or aluminium rod into that. See what happened. The zinc get oxidized. It is going to form +2 and it will fall into the solution, producing 2 electrons. You call it what? You call it oxidation. Right? Now copper +2, from where it has come? From the electrolyte, is going to gain 2 electrons and form copper solid. This is going to be known as their reduction. When you total it, number of electron gain, number of electron lost must always be equal. Mind it, it's important, I'm repeating it. During any chemical process, number of electron produced must always be equal to number of electron consumed. It's a must, right? Remember, this is a basic fundamental. So 2 electron gets cancelled out. You are left with zinc solid, copper +2, zinc +2 and copper solid. Whatever electrons were produced, they were consumed during the reaction itself. So no useful work. What is the useful work here? The electrical work can be obtained from the cell. Correct? So this is not a useful work. We are not going to do that. It is simply displacement, bache. Now please focus. Right? So focus please. It is aluminium and copper sulfate. Here, what was we using? Zinc and copper sulfate. See what is N? What is N? Total number of electron exchange. N is equal to 2. It will be very important for you people. Very soon we are going to hit Nernst equation. In Nernst equation, you have to know what is N. So see what is N. See here. Now aluminium, just keep in mind, what is the common oxidation state of aluminium? It is 3+. Bhakti, यहाँ पे देखो, वो भी clear हो जाएगा. Aluminium loses how many electrons? 3 electrons. Aluminium loses 3 electrons. Now this has lost 3 electrons and copper is sitting in which oxidation state? +2. Copper is going to gain 2 electrons to form copper solid. Are these equal? No, these are not equal. In the previous case, these were equal. So we need not to do anything. So N is going to be 2 only. But here we have 3 electron here, 2 electron here, cross multiply. What is cross multiply? This should be multiplied with this and this should be multiplied with this. So you multiply 3 into 2 and 2 into 3. That means 6 electron produced, 6 electron are going to be consumed. And when you are going to net it, this is going to be the equation. And N number of electrons is going to be 2 into 3 is equal to 6 electrons are going to be produced. 6. N is number of electron, beta. Don't make it complicated. No. Whatever electrons are going to be produced here, electrons are going to be consumed here. N is total number of electron exchange. See, this is simple. This is very simple. This is losing electron. This is gaining electron. So if it gives 6 electron, this is going to gain 6 electron now. How it is possible? It is going to give 6 electron and it is going to gain 5 electron. That is the thing I am saying you. Number of electron produced will be equal to number of electron produced. It should be always equal. So if you see number of electron produced, that is 6. If you see number of electron consumed, that is going to be 6. And here also, it is going to be, please Nayan, what is the value of work done here beta? Did I talk? All direct cell have work done equal to 0, no useful work. So am I discussing anything different? So why are you asking this question? And what is the fun of asking work done here, bache? Just to waste the time of the class, please. So if this is a direct cell, this is a direct cell, you are asking, I don't know why you are asking, is the work done going to be 0? So do you want that I say work done here will be 0 because this is a direct cell? Shall I repeat it again? So see, now you learn N. I'm concentrating upon the useful thing. So is it clear that N is 2 here? I want yes or no from your side. Yes. And is it clear that N is equal to 6 here? N is equal to 6 here. Total aluminium is losing 6 electron and copper is gaining 6 electron. So it is Shomik who is saying, Shomik bolo jara. Shomik mere se baat karo. Shomik baat karo. Shomik ji said कि no. एक मिनट, मैं देख रहा हूं जरा, शौमिक से बात करना चाह रहा हूं. हाँ शौमिक शेट्टी, कैन यू स्पीक? Shomik, I am giving you one more example. This is for final. Now you have to learn it, otherwise I am going to move ahead. Suppose बच्चों, this is silver nitrate and copper cell. Silver nitrate and copper cell. Here copper solid. कॉपर की कॉमन ऑक्सीडेशन स्टेट कौन सी है? कॉपर +2 इलेक्ट्रॉन. सिल्वर इज गोइंग टू गेन 1 इलेक्ट्रॉन टू फॉर्म सिल्वर. करेक्ट? आर दीज इक्वल? नो, दीज आर नॉट इक्वल. यू मल्टीप्लाई इट बाय 1, you multiply it by 2. So what is going to be the n here? N is going to be 2 here. That's it. इसके ज्यादा हम एग्जांपल नहीं क्रिएट कर सकते हैं शौमिक. Then you have to learn yourself. Okay, so this is going to be n, number of electron gain or number of electron ye. Why 3 copper? Who said you 3 copper? Who said 3 copper? 3 copper कहां से आएंगे? क्या आप मुझे बता सकते हैं? तो this is going to be copper solid +2 silver plus. You are going to ask your +2 teacher, +1 teacher that what he or she has.
Yeah, over there. How did you get 3 copper?
Oh, don't worry about the balancing part, Salim. ये आप बोल के बात कर सकते हैं, right? एनायन का क्या होगा, right? हम इलेक्ट्रोकेमिस्ट्री इस साल में खत्म नहीं कर पाएंगे. If you are going to ask question like this, एनायन मैंने कुछ दिखाया? Did I tell anything about anion? It will remain there, बच्चे. This is just wastage of time. So this is just wastage of time, my son. So let me be the driver. Okay, keep your mind to observe rather than ask questions which are not related. Take it as a normal class. All of you are going to school. So if your teacher is teaching you, what you are doing? All of you are standing on the benches and asking questions, sir, like this. So please, let us study. Let us observe. Oxidation state or oxidation number. Oxidation state or oxidation number. It is the charge which develops on an atom or group when it is being separated from its neighbors. When it is being separated from neighbors. First thing is, you are simply given some iron, aluminium sulfate and so on. So what is the oxidation number here? 3, -2, +1, and +2, +2, and +3. Correct? The more electronegative element, this is electronegative. The more electronegative element will always keep shared electron with it. Remember this thing. Say, I'm going to give you example. This is like this. Suppose you have water. I hope you know it, that in each hyphen you have how many electron? 2 electron. So this electron will be kept by oxygen. This electron will be kept by oxygen. So what will be the charge on oxygen? -2. What will be the charge on hydrogen? +1. Why? It has lost 1 electron, and it will be this. Got it? Suppose we have HF. There we have 2 electron beta. This electron goes towards fluorine. So fluorine will be having 1 electron jada, because this was already its electron. So this will be having -1, and this will be having +1 oxidation state. So that is a concept which takes electron with itself. The more electronegative one will take electron with itself. Something very important is coming. Idea was not to teach you the oxidation state of this. Idea was to teach you something else. Now, just keep in mind, this is a fundamental fact. Carbon is more electronegative than hydrogen atom. This is a fact. Out of carbon and hydrogen, which is more electronegative? The carbon is more electronegative. Right? See on the screen. See on the screen. Something very important is going to crop up. Chalo, मेरे साथ करेंगे. This is like 2 electron in every bond. I hope you understand, बच्चों. 2 electrons in every hyphen. That's the case. Correct? Let us work one by one. This hydrogen will lose electron. So what will be the oxidation state here? +1. Correct? This hydrogen will lose electron, बच्चों. +1. हाइड्रोजन गरीब के पास तो एक इलेक्ट्रॉन लूज करने को ही है और वो फटाफट कर देता है. This has lost 1 electron. Any doubt? So all the hydrogen are in the plus oxidation state and +1. Please help me in this. Paul, this electron will be taken by carbon, बच्चे. Correct? This electron will be taken by carbon and this electron will be taken by carbon. Whereas this electron will be shared equally. Why? Both have same electronegativity scale. So neither this electron will go toward this nor this electron will go toward this. So this carbon has gained 1, 2, 3 electron extra. This will be having which oxidation state? -3 oxidation state. Correct?
Okay.
Right. Chalo ji. Now we shifting towards this. Srajan, you will answer. This oxygen will take these electron toward itself out of carbon, and this is going to be more electronegative. So these 2 electron belongs to oxygen. This will be in -2 oxidation state. Correct? And this electron will be lost towards this oxygen, Now let us calculate number of electron on carbon. How many electron left? 2. Carbon के पास होते कितने हैं? 4. तो how many electron carbon has lost? 2. Correct? तो it is going to be, हाँ जी, क्यों? दोबारा चेक करते हैं. तो it has lost 2 here, it has lost 1 2 here. It is having 2 electron with it ना बेटा. तो 4 electron हो गए. एक मिनट. -2 this. It is having 2 electrons. 2 to this, 1 to this. It is 2. एक मिनट रुकेगा. -2. एक second please. -2 is -7. And it is +3. 1, 2, 3, 4 and +7. You are correct. It has lost 2 electron to this and it has lost 1 electron to this. So it has totally lost how many electron? It has lost 3 electron. This is going to be plus 3. Perfectly well. Perfectly well. So we are going to have this type of oxidation state. Minus 3, minus 2, minus 2, minus 7. And this is going to be plus 1, plus 1, plus 1, plus 1, plus 4 and plus 3. This is going to be like this. That is the oxidation state of the carbon atom. Dipesh, I explained with some another example, bachcho. I explained with some another example so that we can practice more. Now you people will be doing that. This is ethanol. Ethanol. Correct? See, this oxygen takes electron from this and from this. Minus 2. Clear? This is plus 1. This take hydrogen. This takes from this hydrogen and no sharing. Now, what should be the oxidation state? This carbon, Davisha, it has 4 and 5. How much electron? It has lost minus 2 here. It has taken from here. You tell me. I do not know. Yes, Harsimar? Plus 1. Plus 1. Minus 1. Minus 1. Minus 1. Minus 1. Minus 1. 4 होने चाहिए थे ना. Now we have 5. Minus 1. What about this? What about this, beta? Oh, no problem. Bacho, this has taken from here. Good. This has taken from here. Minus 3. Right? Minus 3. And this is going to be 1, 2, 3, 4, 5 and 6. So 5 and 6. Plus 6 and minus 6 is going to be 0. Practice more. Practice more after the session. Right? So this is now why I'm going to tell. Yes, check it beta. No, it has 5 electron now. So if you say this has Hanji, say case of this. It has how many electron? 2, 4, 6 and 7. Carbon pe honde kitne hai? 4. So it is going to have on second carbon beta. It has taken 1 electron from here, from 1 electron from here. Right? But it has lost 1 electron to this. So the net gain is of minus 1 electron. ठीक है जी? अब सुनो, I'm taking you to the JEE advanced level questions. This will be asked, although I have not taught you the further thing. Karan Singh Bagga. It is calculate N. I hope you understand N, bachcho. What is N? Number of electron exchange. That is your problem. I'm waiting for your answer. That is your problem. I do not know it. I'm just waiting and answer from your side. I'm waiting. Your question. I give you 1 minute. Workout please, beta. No option, not objective. Every question is not objective. No option. Just type some number 1, 2, 3, 4, 150, whatever it is. This will be very, very important concept for you people. Very soon we are going to correlate it with delta G is minus NFE naught. So you should know N. Chalo, let me do that. Suno, dhyan se suno. The thing will be very important, mere bachcho. Right? Suno. Each oxygen is in the zero oxidation state. Do you agree? Yes or no? Just keep on telling me yes or no. Yes. Now this is going to minus 2 here. Yes or no? That each oxygen is going from 0 to minus 2. Yes. We have 8 into 2, 16 oxygen. Right? So that is 16 O minus 2 will be formed. Each oxygen gain how many electron? 2. total electrons will be, and what was your answer? Got it? 32. अब इधर से देखो, सपोज हम इधर से देखते हैं, तो मेरे अब इसको देखते हैं. दिस इज Showmix in C5H12.
Sir.
हाँ.
Sir, right hand side में there are two oxygens which are -2, right?
No, each oxygen is in a -2 oxidation state here. What is the oxidation state of oxygen in carbon dioxide? -2 here, -2 here. So I will write like this now. Okay, if you want to write complete, then you are going to write like this. Each oxygen is in which oxidation state? -2. Chalo. Now you please mute yourselves, Dolly. Ab suno. This is each oxygen is in the 0 oxidation state. Each oxygen is going to -2. So each oxygen is gaining how many electron? 2. How many oxygen you have? 8 into 2, 16. So 16 into 2 will be 32. चलिए अब इससे देखते हैं. Always remember that n will be always the same, and do not forget to balance the equation before you are calculating n. Chalo, help me out. Do you understand class 11? 5x plus 12 is equal to 0. This is class 11 beta, that you have to learn yourself, right? Oxidation state of this is x. Lisha Didi, 5x is equal to -12. Huh? So x is equal to -2.4. Here the oxidation state, the averagized is -2.4. It is -2.4. I need space, beta. I need space. If you want, I will write it again for you people for notes later on. So this carbon is going to what oxidation state, bachcho? +4. It is going to +4. That means carbon -2.4 to 4 पे जा रहा है. -2.4 से पहले वो 0 पे जाएगा. 0. From 0 it will go to 4. So each carbon will lose how many electrons? 6.4. But now how many carbons do you have? 5. So 6.4 into 5 is equal to 32 electrons. And number of electrons should always be the same. It's a very important topic I'm telling you. Right? Oxidation state cannot be fractional. But when we are going to just check the change, then it will be like that. I agree. It cannot be this. Nishita, Dolly, you know the number line scale? It is -2.4, Nishita. Then will come 0, bete, and then will come +4. From here to here, how many electron gain? 2.4. From here to again a loss, sorry, +4. And what is the total, Vidya? 6.4. Got it? So 6.4 into 5. I repeat again for oxygen. It is O2. Oxygen is sitting in which oxygen state? 0. Just Deveshwar, I rubbed it, so I'm writing it again. It is -2. We are having how many oxygen? 16. So 16 into 2. 16 into 2, it's going to be 32 electron. That is how do you calculate n. I'm going to throw this question after when I'm going to discuss few concepts with you people. So keep on saying what is going to happen. Please listen. Till the time you do not have sufficient knowledge, right? Then you do not jump to hypothetical problems. I hope you understand that, right? Yeah. That is beta where I snub you all. As a teacher, I snub you that you will be doing only the problems which exist. Do not create your problems till the time you have seen the word. K2Cr2O7 plus H2SO4. You remember this? K2SO4 and Cr2SO4 thrice, right? Plus water plus oxygen. Please, this equation is unbalanced. I want to just calculate electron of chromium. So chromium is going from +6 to how much? +3. Each chromium is, Nishita, gaining how much electron, bete? 3 electrons. Sorry, losing 3 electrons. right? How many chromium do you have? 2. So 2 into 6, 3 is equal to 6 electron. Do you remember we took number of electron or valency factor is equal to 6? Yeah, beta. 6 electron lost. Anyway, let's not waste too much time on this topic because we have to tell a lots of more topic to